Okay, can you see the slides? Anyone?
Yes, I can see, Doctor.
Right, thank you. Okay, if you can see the slide, just a recap a bit on last week class. So I have mentioned that, and actually I didn't put announcement in Julian, but I did put an announcement in Telegram. And in last week class, week 5, I already made the announcement and also on the midterm test. So if you came late, then you might not be able to catch the information, but I actually uploaded this notes, this in the notes, chapter 2, so you should be able to go through the notes page by page. Okay, so recap, just a quick announcement. Midterm test for all students, BEKM and BKG will be on week 10. Okay, 17 May 2021. We actually postponed it back to 17 May. We are not going to do it during the midterm exam of FKE week because quite impossible, because you guys have so many so you are from all different types of program and different years, so quite impossible to actually set the time because during that week the English subject you have an exam. I was informed that some students have exam, so we decide that it will be on 17 May. So this one is confirmed. So please make sure that this is always informed. A reminder by my supervisor last time. If you know that you have a deadline, which is we have a deadline on 17 May, Monday, so make sure that you take care of your health. Okay? Take care of your health, take care of your eating styles, your habit, so on, so that you are in good condition. So, and one additional info is that some students, before they go for exam, important things, they go out at night and go makan-makan lah, then riding motor and so on. Thing is that accident happen at night. So make sure that if you are driving at night, be really cautious, of your whereabouts, whoever is driving on. Because if accident happen, then end up you're going to actually, for the whole semester, you're going to postpone it to the next semester. So you won't want to do that. So make sure that you're in condition for whatever exam you're taking. So the exam will be at night, 9 p.m. Venue will be informed, but as mentioned, the venue for the exam will be at Ulan, my Ulan, which is Dr. Mariam Ulan. So which means that all students, doesn't matter from BKM or BKJ, from the 5 class or from the 9 class, they are going to join my Ulan. And that's why in the Ulan, I already asked you guys to select your section group. Means that if you are under my group, the Mariam, then click that. So it's easier for us to actually sort later on for marking. And chapter that will be included for midterm will be chapter 1 and 2. So basically by today, we are going to finish up chapter 2. Okay? So recap on what you have learned in convolution sum. Okay, so convolution sum is the convolution of a discrete time signal, which is when you have two different signal, means that either you have impulse signals or response, or an input xn, then you're going to find an output. Okay, so there are two ways. I have mentioned that there are two types of operation or method for convolution sum. Okay, two methods. Method 1 and method 2. And as mentioned, that method 1 normally is used if your signal is very short. Okay, short means that only have a few impulses. Impulses, not much impulses. But method 2 is used when you have the signal is complicated. Okay, it's best that you use method number 2. Okay, reason why, example, yesterday class, you've given yesterday class method number 2, midterm exam. Okay, so it actually didn't mention that which operation that student should use. What method 2? Okay. The thing is that when you use method 1, they will be neither any graphical graph. So you are going to write only equation. Then if that equation is wrong, then unfortunately you will get 0 marks. Okay? So it means that no marks at all. But if you draw out for method number 2, means that its part, okay, some part may be correct, some part may be wrong, but you actually derive it, okay, step by step. So you have marks. At least half of the marks you have, you see half of the marks. So this is where method 2 is really important to be understood. Okay, and the reason why I emphasize on method number 2 for the convolution sum is that you are going to use this method in the convolution integral. Okay, there's no two. There is only one method for convolution integral for today. Only using the graphical interpretation. Okay, there's no method number 1 using equation. Okay, so there's the reason why I'm showing both. Because some students say, "Oh, wait, what is much more easier?" Well, it's easier, but you have difficulty when you face question in continuous time, which is calculate convolution integral. Okay, so I saw that yesterday, this one, actually, I checked back. Actually, it's not a midterm exam, it's a final exam. Final exam question. Sorry, typo. But anyway, same thing. Final exam midterm means that final exam must be much more difficult, right, than the midterm. But anyway, for the final exam, this one is sample of final exam. And apparently, okay, some students, I think half of students answer correctly and half actually answered wrongly. Okay, wrongly means that in the first part already wrong. This one wrong. Then you can imagine that what happened to question B and question C. Okay? So if A is wrong, then A and B and C, B of, if you see there 12 marks only, 12 marks should be okay. But C is 9 marks. So if you look at this question, actually this, because this is final exam question and it's actually combined, one question, we have chapter 1 and chapter 2 inside. That's why if you see in the first part, the first question, student listening, sebab sangat sunyi. Are you guys here?
Yes, doctor.
Yes, doctor.
Okay.
Okay, I will continue. Right, so if you look at this question, two LTI filter have an impulse response given by H1 delta n plus 2 minus delta n plus 2. Okay, you already and you have another signal which is H2 and UN plus 4 minus UN plus 4. Right? So if you see here, okay, you can directly see that the question is already giving you some hint there. Two LTI filters is that is a linear time invariant signal. Means that it's chapter 2, right? It's already, it's going to, you know that you're going to do some convolution inside this question. Okay, you're going to do convolution. Okay, so that's the one hint lah, but you're not going to check here. So you have, and then you have given two signals, H1 and H2. And for the case of, this is final exam. Okay, like I mentioned, exercise might not be, my exercise is some is a question that for student to understand the concept. It means that in this exercise, I'm giving you some signal, Hn, Xn, and then solve for the convolution, right? And then also for example 2, same thing. Exercise 1 and 2, same thing. You're given a signal and find a convolution. So it's direct. This type of question is only given if it's a closed book exam. Closed book exam means that if you are physically in UTM, so we give you this type of question sometimes, but nowadays, no, this type of question is not given anymore. Okay, the type of question that we're giving is this type of question means that students need to interpret. This is where you have the higher order low taxonomy. Analyze and understand the signal. Okay, so it means that you're given a signal H1 and H2. So you need to analyze the equation. Okay, so you need to do like a K-bar lah kalau you perasaan ni kan, kemahiran berfikir aras tinggi kan. Okay, so you think that you perasaan have a K-bar, but also you see student need to have a K-bar. Tak boleh lah direct question. Too easy for you see student, especially engineering. So H1 given here and H2. So interpret means that from question number A is interpret the equation and sketch the function H1 and H2. So this one is actually referring to chapter 1 topic. Chapter 1 topic. Go back to chapter 1 topic. If you cannot remember what you've done in chapter 1, go and listen to the recording or go to listen to your notes. Hopefully, right now, notes, you have a piece of paper in front of you and take the notes. Take the notes down. Okay, so roughly sketch. Okay, so H1 question. Okay, what type of signal is there in the signal H1? Anyone can answer? In H1? Before we go convolution integral, H1? Anyone write that in the chat? Students should be able to answer. You already submit your answer yesterday. H1 consists of what type of signal? Guys? Unit impulse. Good. Read one. So it comprises of unit impulse. This one, I'm really frustrated with some students. Because for this one H1 question, some student answers step write out the graph for step input. Okay. You know that step input is different symbol and unit impulse. So like Ridwan, he mentioned, he said that it's a unit impulse. Why? Because you see that there's a delta. If you see delta, that is a unit impulse. Okay. So it consists of unit impulses. And what type of transformation do you think? We have that. So still under chapter 1, what type of transformation? In the chat, please. Time shifting. Okay, Natasha, good. So we have time shifting. And the time shifting that we have in this question is that we have both time delay and time advance. Okay. They are both in this question. We have n+2, which is time advance, and n minus 2, time delay. So you already can imagine, oh, the signal looks like. What does this signal look like? It looks like this, 0, 2, minus 2, 1. Okay, this is signal H1n. Very simple. If you understood chapter 1, and this one is a very simple signal actually, H1n. Okay, but still, student confused. Okay, I'm worried, really worried about you guys for final exam question. Yeah, I'm actually the one drafting the question. And if you cannot interpret this type of question, then you're in a big trouble. So make sure that you're able to actually read the equation given and translate it into a signal graph. Okay, and H2. And what type of signal do we have there, and what type of transformation do we have in signal in H and signal? Anyone in the chat? Kenapa lah today very bad only 2 person actually answer in the chat. Muhammad Ridwan dengan Natasha. What happened to the rest of students? Is there any delay from my side or what happened? You cannot hear me? Okay, what type of signal do we have for H to N? And what type of transformation? Guys? Okay. Two people reply. Muhammad Zulhakimi. Okay. We have unit step. Okay. Right. Very good. So unit step and then Lee Jiajin, unit RAM. Correct. Also, we have RAM there. Ong Yi Sui mentioned unit step, time shifting, and amplitude scaling. Okay, amplitude scaling might not be correct, but okay, acceptable. I would say acceptable because amplitude scaling is that when we actually multiply the RAM with the unit step. Okay, so let's look at where was the unit step. So unit step is this. Okay, UN. So delta N is impulse, N is unit step. Okay? And then you see that you have plus 4 and minus 4. So you know that unit step, you're going to have a shifting. So the first signal is that you have a unit step shifted by minus 4, right? And then another one is you have had shifted by 4. But the question here is that you have UN plus 4 minus UN minus 4. So what happens that these two signals, you need to minus it. Okay. So in the end, you will get only this signal. Then the rest is 0. Okay. So this one is answering for this question. Like what Win mentioned. And also Lee saying that we have the unit RAM. That's correct. We have the unit RAM. Okay. And then after scaling. So we have the scaling. So unit RAM. We have 0 here. Unit RAM N is like this. So meaning that the signal that you have here is this type of signal. Because you already multiply it unit RAM. Okay, amplitude scaling. Something like this. Okay. So that one will be answering for question history. And done. If you can answer that, then you can get 4 marks. So you know what you answered. Okay. So I think some students get 0 for that question A. But some students get full mark. And B, question B. Okay, assume that two systems are connected in parallel is shown like this. So determine the impulse response Yn for the parallel system interval of H1 and H2. So actually for this question is that they asked you to calculate Hn. Okay, calculate Hn. Some student actually messaged me yesterday, but like I mentioned, I have the whole day I have a meeting. So I didn't check the Telegram. Okay, only after 5. Check that trigger. That's why after 5 only I respond to the Telegram. And then, so some question student ask. For this question is that we don't have signal SN. Memang tak ada. Okay, there's no signal SN. So actually, this question B is to calculate what is Hn value. And in chapter 1, this is also still in chapter 1 topic. Chapter 1 topic. Chapter 1 topic. You have learned that you have when you have two signal, okay, addition there here. This is similar like the We prove for even signal. Even signal, you remember two signal add in, and then you get y this hn, right? So this is what it means. Just add this two signal h1 and h2. So just plot what is h. So you will get that answer. Okay, I'm not going to plot that. Okay. In the D, apply doctor for the h1, delta n blah blah blah, and the n2. And 2H1 should be at -1. Yeah, it is according to the RAM value. This, of course, this in the arrow is not correct. RAM value, you know, when you plot RAM value, what happened? RAM, this is 1, 1, 2, 2, 1, 2, 3, 4. So actually, you have the signal like this, kan? Okay. After doing that, just remove that. Okay. And you have -1, -2, -3, -4. The first signal. What first signal? This one is RAM value. Sorry, not RAM value. H2N. Already multiplied with the RAM. First signal H1. H1N plus 2 minus delta N minus 2. N2, H1 should be at -1. Oh, yeah. Correct. Because you have this minus. So, sorry. Minus. Okay. Very good. Okay. This one example. Like student lah. Mistake. So, minus. Make sure that you check correctly your answer. Minus. So, when you add these two signals, you will get the signal that you get lah. You add this H1 and H2. Okay, correct. Lee, okay. Okay, so just add these two signals, then you get the answer. And then for this question number C, okay, assume that the two systems are connected in cascade. Okay, you have H1 just now, you draw it out, and H2. Okay? You determine the response for Hn. So actually, this one, find what is Hn, which is, this is in chapter 2, convolution sum. So H1 times H2. Yeah, this one is, I really panic looking at some student. Okay, they answer H1 and H2 by multiplying only the signal, multiplying only the amplitude, and not doing the convolution sum. Whew. I just taught you convolution sum, and this topic is convolution sum. So, oh, please, I have mentioned that, of course, in this question, you're not going to be that guided, not guided question. The open book question or even closed book question in the hall, you're not going to be guided. Guided means that, okay, for this question is that you're going to use convolution integral or convolution sum. That is guided, very guided. Means that student no need to understand. Oh, for this, if this is a discrete time signal, I need to use convolution sum. Okay, so this is that is means not guided. Student need to understand the concept of what you have learned in chapter 1, chapter 2. So this is unguided question. It doesn't mention that you need to do convolution, but you were actually being taught that, taught ni teach lah past tense tak tahu pula taught ni kan. Okay, so H1 times H2 is convolution. Do the convolution sum. Itu maksud dia. So, do the convolution and get the answer. So, I saw that some students get the answer correctly, but some didn't. And I saw that I think one student did the method 1. I am not sure. Even method 1, you didn't draw out the graph. And then suddenly you get the answer, final answer. Final answer, you plot the HN only. Okay? Without without substituting any value of this at 1, 1, 2, 2, and so on. You didn't substitute. So I assume that you copy paste. Okay? So if you don't want me to assume that you copy and paste, even though you are very genius, please. I know some students are really genius. They can actually just snap their finger and then they can come up with the answer. Okay, but don't shorten the answer by giving the final answer only. Please write out the steps. Why this? Look at these marks. Okay, this mark is 9 marks. If you only draw the final graph, means that you draw only HN, you might only be getting 2 marks only. You imagine that 2 marks out of 9 marks. You got the final answer correct, but because you actually omitted the steps. Okay, I'm not sure why omitted the step is because of copying from friends or something else. I do not know. So you just come up with the final answer. So unfortunately for this, either way, if you want to explain or justify your answer, you still get 2 marks because we have a rubric of marking. That graph, final graph, HN is only 2 marks. The other marks is from the steps. Okay, so hopefully all students are clear about this. Okay, right. Just show. I will just show the answer. One answer the student submitted. I already checked who student there, but didn't manage to check all. But I know who to actually answer correctly. Okay. Oh yeah. Then sini macam ni. Alright, so Muhammad Hidayatul ni, okay, I already checked his answer. So this is actually correct. So he answered A, yes, and B. Okay, correct. Then for the B, answer this. Okay. And then for C, we did the convolution sum. So your final answer, you will get this H and A. Of course, for my reference, I will actually to actually correct mark this question, I will just directly go to the last convolution C. Look at the signal graph that you get. Oh, if you get this answer, then I will assume that all of the answer above A, B, C is correct. So I will just look at the steps. Okay, correct. Oh, okay, okay. This student, this one I mentioned, student is using method 1. But method 1, he didn't actually substitute anything. So Hidayatul, make sure that substitute. If you want to use method 1, please substitute the value that you have here, 1, 2, 3, and so on into this. Okay, do not just write an equation. Okay, this is method 1. But I would not suggest method 1 since if you do a mistake, then you're going to get marks. Not 0 marks accordingly. Okay. Okay, this one is, hopefully this one is using graphical method. Okay, this one is method 1 juga, hopefully tak miru lah ya. Because student also didn't write, insert the value for the amplitude there. The method number 2. Oh, okay, ini wrong. Sorry. Wrong. Okay. Low, I think low punya. Wrong juga. Okay, sorry but this one is not just to make student feel bad, just to share. Okay, dulu. Okay, ni betul, correct. AB betul. Betul. Alright, this one is graphical method. So graphical method, you see here, graphical method, it's not that actually complicated to do graphical method. You can answer the question. Okay, this is C. She's doing, he or she is using the graphical method here. So you see one page, then you can directly see, look at the answer, and then you can actually check your answer is correct, then plot it. So this one is correct. Okay, so use graphical method. You may think that graphical method is difficult, but it's actually not. Okay, so any question from student before we go to convolution interview? Any question?
I have question.
No, okay, right. Okay,
Uh,
so
for, I have question. For the H2 equation.
H2.
H2 equation. When we want to subtract with the H2, when we want to subtract, there is one interval that I am confused. At n equals to 4, there is positive 4 and negative 4. Should we cancel out the negative 4 or not?
Yes. So it's until 3 only, right?
Yes. So the RAM is until 3 lah.
This one is, sorry, wrong. So until 3 only, okay? You need to cancel it, okay? All right, yeah. But just now the student who answered gave the answer that I said correct in the Yulan is correct answer. So this one is from minus, we have the value from -4 until 3 only, okay? Right, any question? No, All right, if no question, then we go to the convolution integral, okay? Okay, so convolution integral is similar to the discrete time, which is instead of terms of pulses, you are going to have the signal in terms of continuous time. So actually, if you have reference book, you are referring to reference book, those who are in them, if you refer to reference book, usually we'll look at, how the book explains that you're going to do convolution integral first. Okay, then only go to convolution sum. Even for the lecturer teaching session 1 and 2, and 2 and 3, they also teach first convolution integral and then convolution sum. But the thing is that because I have teach the signal system like I think for 10 years, I think 10 years, and I found out that if start to deliver first convolution integral, it will make student panic. Means that, oh my god, this chapter 2 is difficult because suddenly go into integral. Okay, integration. Student don't like integration kan dengan derivative, and so that's why I start with convolution sum first. Convolution sum is more relaxed because it's summation only. Okay, but the idea is the same between convolution integral and sum. Okay, so if you see here, same to the convolution sum is that any continuous time signal can be expressed as proposition. It means that it can be shifted continuously for the things for the discrete time is that in pulses, but for the continuous time is that in terms of continuous time signal. Ada statistik. Alif ni tanya siapa ni? Lepas ni dah tak ada kelas tu. I think is salah apa window orang cakap dalam WhatsApp, salah tingkap kan, tanya kat saya tak tahu lah you ada statistik ke tak kan. But anyway, I don't know statistic in the subject ke static class, I'm not sure. Okay, anyway, so if you see here is that when you have the import xt signal, it can be defined as a time shifting. So you have x tau delta t minus tau, okay, and Similar goes to when you have this type of block diagram. Okay, same thing. Instead of looking at the convolution sum, you have the signal in x tau. We in here we take it as x tau. Okay, if it's in convolution integral, then it's in xn. So yn before this is convolution integral. So imagine that this one is discrete time. This one is in continuous time signal. So this one is discrete. Right? So same thing, same way. And you can see that how to actually calculate for yt, which is this one here, okay, is that you have the integration of x tau, h tau, tau. Okay, so in contrast, let's look at the convolution sum equation. Okay, so convolution sum equation is that you have yn summation. The difference is that summation, okay, xk, hn minus k. And in contrast to the convolution integral is that this one integration. Okay, so it's a bit different. One is summation and one is integration. So this is where this is the reason why I do not teach convolution integral first. I teach first the concept of the shifting mean for the convolution using convolution sum first. Means that summation with integral, which one is more easier? Of course, summation. So that's why I start with convolution sum first. Right now you have an idea of the concept of convolution, okay, using method 2. And as mentioned, for the for the continuous time signal, there is only one method to calculate. Okay, method number 2, which is the graphical method, and that is the reason why I'm emphasized on the method 2 in the convolution sum previously. So understood that reason why, okay, to come up to actually answering convolution integral. So convolution integral is given by this one. Same thing. You have yt equivalent to the integration of minus infinity to infinity x tau, h minus tau, tau. Okay, and so if you were to write here the convolution sum, yn summation of minus delta infinity into infinity xn h and minus k. Okay, so this is the comparison. So same thing, you have the shifting. Either you want to shift h, you want to shift ht minus tau, or you want to shift xt minus tau. So same concept with the convolution sum. And as mentioned, the one that you want to, the signal that you want to shift should be the easiest signal. Okay, pick which signal is easier, then shift that. Okay, so symbolic representation of the convolution integral is given by this one. Yt. Make sure that don't forget it need to be in star. Ht. Okay. This one is the operation of integral, a convolution integral. Okay. That's mentioned, only one method, okay, which is similar to the convolution sum. Okay. So the step 1 is the impulse response. Okay, time is time reverse. So we are referring to this equation since we are going to shift this ht minus tau. So assuming that this ht is the simplest signal, so shift the simplest signal. Yeah? So shift it, time reverse ht, make it into h minus tau, and then then shift it by t, make it into ht minus tau. First step, same thing to convolution sum. Next is that signal xt and ht minus tau are multiplied together. The product of the xt method is integrated overall to produce a single output. So this is where it becomes a bit difficult, a bit advanced than convolution sum. Okay, because we have the integration. Yeah? And then to produce xt, yt, and then repeat it over minus 3 to infinity, and minus infinity to infinity. Okay, So similar to what you have learned in convolution sum, you want to start with the signal where it does not overlap. Okay? Find the t value that it does not overlap. So in convolution sum, you find the value of k, which is the signal does not overlap. Okay? Then you get that value first. Then next you start to overlap it and then shift the signal. Okay? So let's go to first example. Okay, take out a piece of paper. Let's look at this example. Nampak tak? So, right? So the question is that okay, suppose this one is where you need to have skill of reading the equation, yeah? Because you are not given any signal in terms of continuous time. Right? So suppose that okay, xt is equal to ht equal to pt. It means that you're given a signal xt is not given here. Anyway, where pt is given by this value. Okay, so meaning that what it want to actually explain that okay, from this one question, I can actually draw out what an idea of how does it look like the block diagram. So I want to draw out. I have ht there. It's here xt. Sorry, ht. Then I have the input xt, right? Then you know you have the output yt, right? So I can interpret this into this block. Okay? So some question in a finite exometer, you're not going to you're not going to give you this block diagram. Okay? You need to be able to interpret it from the sentences, right? Where xt and ht have the same signal, it's given here, and is equivalent to pt. Okay. You are given the signal pt here. Okay. So what you need to do is that first of all, draw out the signal t. Okay. But before that, let's look at what the question asks. So find the convolution integral yt and sketch the output for the system. Means that this signal is direct because it's already asked you to find the convolution integral. Then you should know that you're going to do a it is a continuous time signal and you need to do integration later on. Okay, so convolution integral means that you want to find out what is y equivalent to x convolve because it's convolution integral h t. Okay? So meaning that you need to draw out first what you need to draw out the signal pt. Okay, so let's draw out the signal pt here. Okay, I'm going to draw. Let me draw it here. We have t pt. Okay, let's look at this. Pt equivalent to 1 for value of 0 to t, okay, and 0 for other ones. So other than that value above, then it's 0. Okay, for this case is that I'm giving you a value that t equal to 1. So just slash that out, t equal to 1. Okay. So we can draw that out. So you have 0, 1, right? And then I'm going to draw out the block because it's a continuous time. 1. Okay. This one is PT. Okay. And you know that this PT is equivalent to XT and HT. Oh, I can draw that. You want to draw see. Let me just draw it here. Is it too small? Oh, okay. Right. So let's look at this. So we have already this one here. Okay. Okay. So now you can start doing the convolution integral. Okay, how to do the convolution integral is that you need two signal. Okay, you need two signal. You already know that you have yt equivalent to xt combined with ht. Okay, and for the convolution integral is that you have the equation given by minus infinity into infinity and x tau ht minus tau. Okay, so yt. So this is the signal, not signal, the equation. Okay, so similar to convolution sum, what you did was that you're going to draw out online. Draw out first the signal that you're going to fix, which is this one, right? Signal. So x tau. How do you know that you're going to fix that signal? Because based on this equation, you know that x tau is x tau only. It's not going to be shifted. But the one that is being shifted is ht minus tau. Okay. So you're going to draw that out. So x tau 0, 1. Okay, we have x tau here. Okay. Now we are going to draw ht minus tau. So ht minus tau, as mentioned, we have the few steps. You know how to do the convolution integral method. So from h tau, okay, we have ht h tau, change it to h minus tau, then h t minus tau. Okay, so meaning that if I were to draw this out, since this one, ht is this one, kan? So I'm going to draw this one as 0, it's 1. Okay. And then this one is, we did it for this one, h minus tau, h tau. Okay. Now we want to add ht minus tau, so t, then we add the t value, t minus tau, so it becomes t minus 0, it's 1. Okay. So this is how you start off with the convolution integral, which is similar to what you have learned in convolution sum. Okay. So, okay. So now we do the convolution integral. Okay. So for the convolution integral is that we need to find the non-overlapping value. For signal xt and h tau. Okay. So step number 1. What is the non-overlapping value? Non-overlapping value, which is for t, t for signal xt and h tau. So this t value. So let's put there t. So different color, so t. So we have t. What is the value that is not overlapping? ht minus tau not overlap with x tau. Can you guys write there in the chat? T, what's the value? Guys? Same like in convolution sum, what's the value that the signal does not overlap? Guys? Can you unmute your mic? Answer a bit. I'm not sure. Is it delay on my side? The chat, nothing is going out. Okay, Famel. So Famel say 0. So correct. So the non-overlapping value for T signal is okay. I'm going to write here for T less than 0. Okay. So let's look at the value. Is it correct? So T is 0 or minus lah. So T, I'm going to write there T is less or equal to 0. So you have there T minus 0, 0 and minus 1. Okay. So for this case is that I'm going to draw out over here this signal so that we can look at it together. So okay, so for T equal to 0, okay, just now, you have the value at 0 and minus 1. So 0 and minus 1. It means that it is value. So you see that there's no overlapping. So you can write equation yt equivalent to no overlapping. So actually for this value, I'm going to directly write. You can write there the full equation if you want. Minus infinity x tau h t minus tau d tau 0. Okay. So next we are going to look at for t equal to 1. So t equal to 1, 1 minus 0, 1, and then you have 1 minus 1, 0. So we are going to draw that out. 1 and 0. So you have the signal like this. Okay, overlapping directly again, 0 and 1. So for this case, we're going to write for t equal to 0 and yt equivalent to integration. Okay, look at this one. The integration is that you look at the value where the two signal is overlapping. So you see that both signal are overlapping from 0 to 1. Okay? So you have 0 and 1. Okay, 0 and 1. Okay, x tau. So just take that value, h t minus tau d tau. So you have the 0, 1, x tau value is what? X tau is the what color? X tau is the blue color. So x tau is the blue color, the value is 1. Right? So 1 time ht minus tau, which is the red graph. Yeah? So also the amplitude is 1 d tau. Okay? So the integration of a constant. What do you get? Integration of a constant. You get tau. Okay? So 0 to 1, then you get 1. Okay, so yt, you have 1. That's the value of integration for that. Okay, so next we do for the following. We continue same like what you did in convolution sum. So you continue to, okay, until the signal not overlapping again. From before, not overlapping, 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 overlapping until it's not overlapping anymore. So we test again for another t value. So you have 2 and 1. Okay, 2 and 1. So it means that the signal is here lah. 1, 2. Right. So this one you can just directly eyeball that it's not overlapping anymore. Right? So T2 YT, sorry, different color. YT, no overlapping, so I'm going to directly write there 0. Okay, so this one delete because already finished. Okay, with the integration. So okay, after that, since you already get everything, we have to calculate from 0, from the value of non-overlapping right here, and then up until it's overlapping, and then not overlapping anymore. So we are going to plot the yt. It's similar to what we have learned in convolution sum. So plot yt. Okay, plot yt. The value. So yt, we have the value from okay, right there. When you can write 0 minus 1. It's 1, 0, 1. Plus 2. Okay. So you have the value t minus less than 0, you have 0. So means that 0. Everything means is 0. Okay. And then t equal to 1, you have 1. 1. And then t equal to 2, you have 0 again. Okay. So basically, you can write here t equal or equal to 2, you have a 0 value. Okay. So amplitude is 1 just now. Okay. So in the equation, in the question, it says there, sketch the output of the system, so which is what yt. Okay. Then, but based on this answer, in some question is that they ask you to write the equation. Write the equation of yt in terms of some signal. Means that you need to write it in terms of like what you have given in the P2 value. Okay, so you have yt. Okay, so you can see that value for t less than 0 is 0. Okay, between t and 1, you have a value here, a RAM value. Okay, which is you need to calculate. This one you have learned in chapter 1. Okay, and then what else? You have another signal here, this RAM. So actually, if you were to divide this, you have this signal is divided into 4 region or 4 equation, right? So meaning that you need to have 1, 2, 3, and 4. Right? So to colorful, and then another one is that let's look at the region number 3 here. So it's between 1, t, and 2. Okay, you have a signal, calculate that. And last one is for t more than 2 is 0. Okay, so how do you actually calculate for this one? Okay, remember, you can use the equation y equal to mx plus c. you know that you have the value 0, 0 here, you have the value here, the coordinate 1, 1, and here is that you have the coordinate 2, 0. This one is 0, 0. Okay, so you, for this number 2 here, you need to find what is the m value. Okay, m value. Okay, so you can use at the point coordinate 1, 1 there, 1. Okay, so y equal to 1. M for this slope is what? 1 lah. Okay, and then x value is 1 plus c. So c you have 2. Therefore, y for this equation you have x plus 2. Sorry, this one. A student actually listening, I'm doing the wrong calculation. Okay, so sorry, I didn't notice that this one is actually at 0 point, and then you have the m sub is 1. So actually you can directly write here that the value for between 0 to t, 0 to 1 is t only. Okay? The next that you want to calculate is actually this slope. Okay, this slope. Okay, so the m value, you know that the m value is for this slope for number 3 is minus 1. Okay, so 1 minus 1, 1. So you get c equal to 2. Therefore, you can write the equation as minus t plus 2. So this equation become minus t plus 2. Okay, so this is how you write the answer, plot the graph, and write the answer. Okay, any question? Any question before we take a 5-minute break? This one is a very simple question. Later we are going to so that there's the chat no question. Okay, very good. I assume very good lah, since you understood kan. So we have done in for the first question. Okay, if you see in the notes, I actually show to you the case 1, 2, 3, same thing actually. Okay, but actually explain it in more detail. Okay, now next while we have the 5-minute break, please look at this exercise 3. Convolution integral, same thing. Okay, I want you to draw out the signal xt and ht first. Then we try to do the convolution integral together. Right, 5-minute break. We continue back, or 5 minutes, 7 minutes. We continue back at 9:20. Right, thank you. Alright, guys. Okay. Screen. This one, exercise. So exercise 3. So have you drawn the XT and HT value? So let's look if your answer is correct. We are going to do it together. Okay, and by the way, okay, I forgot one last thing. For the signal plot XT, you can check if your signal is correct. So how to check? To check length of XT. Sorry, very bad writing. And length of HT. Okay, only this. The length of XT is 1 plus 1. Length of HT is 1, just now. So you have 2. So you should be able to have the length means that the plotting is 2. Okay, so in contra to the convolution sum, you have the length is minus 1. So quick check for convolution. This is only valid for convolution. Convolution integral. Okay, so quick check that one. Now we go to this example. Okay, given the input xt, okay, and impulse response for continuous time signal as follows. So as mentioned, you need to draw out what is xt and ht. So from here, you might not, okay, which one is the more simple signal, but if you already do lots of exercises, okay, exercises, it doesn't mean the exercise that we do in class that I force you to do or submit, no. We have tutorial, you can do it on your own, or even the exercise that I give you in slide. Some exercise that I don't mention that please do the exercise. You can do it on your own. So let's draw out for xt. Here. So we have 0 to 1, 0 to 1, we have 1 value, and the other value is 0. So basically, it's like this. Okay, 0 to 1, we have a value, okay, and the rest is 0. This one is xt. ht, you have from 0, 1, 2. 0 to 2 is 1, and the rest is 0. So meaning that this is how the signal look like. Okay, so for this case is that you can either, based on the equation, this is the equation, yt is given by integration of minus infinity to infinity xt ht max tau. Okay, from these two signals, which signal do you think is more simple? Is it signal xt or ht? The signal? xt, okay, xt, So xt, so because of that, we are going to actually shift the simple signal. So if you see the signal is xt. So based on this equation, we are not going to use this equation, but we are going to actually use this h tau x t minus tau b tau. Means that we are going to shift this x t minus tau. Okay, so fix that value. Means that h tau is going to be the one that's fixed. So I'm going to draw h tau first. 0, 1, 2. We have 1 here. Then this is h tau. Just save that. Okay, so we have x tau, xt here. We're going to shift it. We're going to have the x minus tau and then x t minus tau, right? So we have 0 to 1, so you're going to shift it 0, different. Then you have minus 1. Okay, you have x minus tau here. Draw that out. Then looks same. So I'm going to remove that first. Okay, this is 1. So because you have put it t, so you have t minus 0 and t minus 1 over here. Okay, so you're going to write, find the non-overlapping value for t. Okay, similar like what we did. So non-overlapping t value is for t more than 0, right? So t0, 0, minus 1. Okay, so you can check that. Okay, you have the value for x tau is from minus 1 to 0. So minus 1, minus 1 to 0. So there's no overlapping. So you can write there y 0 if you want. Then minus infinity to infinity. Remember your equation, you use h tau first, h tau, x t minus tau, tau, then you get 0, for y 0. Next, we are going to test out box.
Madam,
Yes.
can I know why is it t larger than 0, not smaller than 0?
Oh, sorry, it's correct. It's t smaller than 0. Okay, t smaller than 0. Thank you for correcting me. Okay, is t smaller than 0? Means that for t smaller than this value, means that if you test out t equal to minus 1, you still get 0 for 0 also. Okay, so if you want to confirm, you can confirm that. You can write. Yeah. Okay, plot out again. So t minus 1. So if t minus 1 is minus 1, minus 2, then just now, because I said that it's not more and less, sorry, t minus 0. So you have 0 minus 1. So you can see that if it's minus 2 minus 1, then your signal still is not overlapping with the HT value. Okay. So that's the answer. Okay, it's typo, sorry. So next is t equal to 1. Okay, t equal to 1, you have 1 and 0. So this so you have y1 equivalent to, you have from 1 to 0. So you have 0, 1. Okay. So the overlapping area, if you see here, is this one, right? Okay. So meaning that how you write it is that you are going to integrate from 0 to 1 h tau. I'm going to directly fill in the value there. Oh, okay. I write first the equation. H tau x e minus tau tau. Okay. So what is the value for h tau? H tau is 1. Xt minus tau is the red color, is also 1. Okay, so that's why you write there 0, 1, 1 times 1, t tau. Okay, so integrate that, integrate a constant value, you get tau lah, 1 tau lah sebenarnya. But integrate that tau ni, tau 0 to 1. So you get 1. Okay, so this is for y equal to 1. Next, okay. Next is for t equal to 2. Okay? So 2 minus 0, 2, 2 minus 1, 1. So write that, draw out the equation. You can write here first, t equal to 2. We are going to 2 equal to 2. Okay, 2 equal to 2 is a 1 and 2, right? So means that this signal. Okay? So this overlapping area. So write that out, 1, y at 3, y at 2, equivalent to, integrate from 0, 1 to 2, 1 to 2. Okay, I'm going to directly fill in the value lah. I'm not going to write the equation again. So we have the value 1 times 1 tau. So you get tau to 1. So you get 1, 2 tau, you get 1 value. Okay, I'm going to be a bit fast right now. Not going to finish. So t equal to 3. So 3, 3, 2. So t equal to 3. So t equal to 3 just now is at the value 2 and 3. 2 and 3. So there's no overlapping area anymore. No overlapping area. So y3 equal to 0. Actually, after that, if you check for y4, also you get 0. So 4 and 3. You see that 4 and 3 here, also at this point, you still get 0, no overlapping. So that's why for this one, I can write here t more than 3, you get y3 equal to 0. Okay, so because right now, just now, when you do the equation, you know that at its value you get 0 and then you get 1, 1 and then 0 back. So now you know that, oh, I'm at the end of the equation. Okay, so what you do next is plot. Okay, plot yt. So axis first, you have the value 0, 1, 2, 3, 4. Any question?
Doctor, can you repeat just now, because suddenly just now we lost connection with you around 2 or 3 minutes. You don't see the record actually.
Really?
Yes, Doctor. We cannot see
Yeah.
the graph.
Yeah, we cannot hear or see anything.
I thought my internet lagged. I think everyone has the same problem.
So, okay, where did you actually start? Just 3 minutes. 3 minutes means that kat mana?
We start from the part when you want to plot the YT.
When you want to plot, when you just starting to plot
This one?
the YT,
Yes.
Oh, this one. Okay. If that one, then I will draw again the plotting on the right side. Okay. So plot again, plot YT. Right. So T minus 1, right out first, you have the T value 0 and minus less than 0 is minus 1. We just put extra there, 1, 2, 3, okay. So for Y0, just now, you know that less than 0, you can plot it at 0, okay, because you have the 0 point there. And then for T equal to 1, is that you plot it Y at Y equal to 1, so 1, okay. T equal to 2, you have 1 also. And T more than 3, you have 0. So 3 more than 3 is 0. So just connect the dot. Okay. So based on this, okay, you need to find out what is the equation YT. Okay. YT. So as normal, look at this graph, plot Y. So how many region or case do you think that we have? So region lah. We talk about region. So we have first region means that less than 0. So T less than 0. Second region is this one. This one. For 0, T between 0 to 1. Then next region is this one. Between 1, T and 2. Third, fourth one is this region. 2, T and 3. And last one is this T more than 3. Okay. So for the first region, this one is very easy. So YT, T less than 0 is 0. Okay. Next, second region is that it's actually similar to the previous example. So for between 0 to 1, you have the T value lah. Okay, because it's a linear graph, right? So M here, if you eyeball it, is M is actually 1 and the C cross section is at 0. So that's why you get the T value. Okay. Third is between 1 to 2, you have the 1 constant. So you have 1. Okay. The fourth one is that between 2 to 3, this one you need is a bit tricky, but not that tricky. So calculate what is M value. M value. So M value I think is roughly minus 1. And C value. Calculate what is C value. Okay, so this one I give you the task to complete this. What is the equation? And lastly is that for T more than 3, you have 0 value. So this is how you got your YT and then come up with the equation for YT. And you can do a quick check. Okay, for convolution integral is that the length of xt, so xt just now is 1, kan? This one, 1 plus length of ht, 2. So you get 3. So you can see that actually the graph length is 3. So your answer, you can do a very quick check that your graph is correct or not. Sometimes you may want to, when after you plot xt then ht, you can do a quick check first. Okay, calculate, okay, 3. Means that you know that you will have a value, okay, means that between this 3, the length of t is 3, okay? So you can estimate lah, means that you know that you don't need to calculate for t equal to 4, okay, or t equal until t equal to 5, okay. This is based on much practice by student. Alright, understand? Right, so if understood that. Okay, this one is another task, the exercise 4. Okay, I'm going to ask you to upload this in Padlet. So in Padlet, I already upload this in Padlet. So try to do it, not now lah. Later on when you have time, you upload this. So that this one is a very simple exercise, but it looks the same as what you have just now, what we did just now. But this is slightly different. If you see the equation, if you see the equation, you see that for xt is you have 1 between 2t, so let t equal to 1, so you have actually 2. And then for ht is that you have 2 equation, so 2 between 0 to 1, and then 3 between 1 to 2, right? So mean that for the equation xt, what you need to do is that you need to draw out what is the signal for xt again. So you have 0 to 2, you have the value is 1. Okay, this one is xt, right? And then you are going also to draw out for signal ht. So ht you have from 0 to 1, okay, it's 2. And then between 1 to 2 is 3. And the rest is 0. Okay, so same thing lah, rest is 0. So based on these two equation signal, okay, which one is more simpler? Okay, the simplest signal is the one that you need to shift. Okay, so if I were you, the more simple signal is xt. Okay, so I'm going to shift that xt, shift from before overlapping until it overlapping, and then until it non-overlapping. Okay, and then plot for the yt value. Okay, so this one will be an exercise to upload in Padlet. Okay. Actually, I wanted to do last exercise. This convolution integral, but we don't have time. But anyway, the same concept, just that. Okay, we have time lah. I try to make it very fast because this one is a bit different from the previous exercise that we did. Okay, where previous exercise the signal is simple signal, step into signal only. Yeah, but for this case is that you have a ramp signal. Okay, ramp signal. So meaning that you need to understand. I'm going to write out for the integral. Okay, for constant value. Integral of constant value. Okay, and then integral of variable x dx, you will get x. Okay. And then square root, you have x squared. I think you have learned this in maths kejuruteraan during maths. Okay, so this one is a common equation for integration, which you need to know in this convolution sum. Okay, so based on that equation, okay, we are going to do the integration. So let's look at this signal between signal xt and gt. We have two signals given, xt and gt. So which signal is much more simpler? Okay, the signal that is simpler is actually xt. So based on that, I'm going to fix the signal gt. So I'm going to fix signal gt, and then I'm going to shift signal xt. Okay, so xt, if you see xt is our value amplitude is 1, and from -1 to 1. So basically, if I write it out, then I can actually write it become the t, x t minus tau. Okay, this one is t to tau. So you know that because we are going to flip, but because it's the same value for t, so you have 0, t, and minus t. And then because you have a t minus tau, so become t minus tau, and this one become t plus 1. Okay, so the signal is given by amplitude 1. Okay. So we are going to find what is the non-overlapping value for t. So non-overlapping value, non-overlapping, okay, overlapping value for t is 0 lah. So not 0. What is the non-overlapping value for t? Okay. Why I cannot? Okay. Okay, the non-overlapping value for t is actually at -1. Okay, so -1, you get 0, minus, sorry, ni bukan 0 this is, so become t lah, t minus 0 so become 1, and then you have -2. So if you look at this signal gt, okay, I'm going to for t equal to -1, not overlapping area. So you can see that we have -2 until 0. So we have -1, -2. So this is the signal just now, xt. So you see that this signal xt minus tau is not overlapping. Therefore, you can write it out as y -1 less than 1 juga pun boleh, is equivalent to 0. So next you're going to test it out for t equal to 0. So you have 1, 0, minus 1. Okay. It's 1 minus 2. So you have the value different color lah, put t equal to 0. So you have -1, 0 yang ni 1. So overlapping error is this part. Okay. So means that you are going to integrate y at 0 is from 0 to 1, okay, the value for this xt is, because you are going actually shifting, so y original equation is minus infinity into infinity. The signal that you fix is gt dot xt minus tau. So means that you're going to write out gt first, kan? So gt is the value here. So I forgot. Okay, actually before you start, you need to calculate what is the equation for gt. So equation for gt, we find it using the y equal to mx plus c. So actually you can calculate that m is actually equivalent to 1 over 3 and c is 0. So this signal is represented by 1 over 3t. Okay? So the way I write this signal, okay, is that I'm going to substitute value 1 over 3t, okay, based on the calculation that I derived here, 1 over 3. So I have the value of g. Okay, I'm going to enter it here, 1 over 3t multiplied by x minus tau is this value, 1 tau. Okay, so this one is that you are going to integrate a variable x tau. Okay. So meaning that you will integrate from tau squared, can take it out, over 2, 0, 1. Okay, so what do you get? Tau squared over 6, 0, 1. What do we get? One over 6, eh? Okay, so y0 is 1 over 6. Okay, good, you understood that. So next is t equal to 1. T equal to 1, you have 1 plus 1, 2, 1, 0. So you have 0, 1, 2, 1. So this one overlapping. Okay, so you can write y1 is equivalent to, from 1 to 2 here, 1 to 2. GT value is 1 over 3 tau. The value for the xt is constant y and d tau. So you will get same lah like this one, kan? So I write here 1 over 3 tau squared over 2. Okay, 1, 2. So you will get the answer is for t 1 is you will get 4 over 6, kan? Okay, 2 squared. So kan, oh sorry, this one is not 1 to 2, it's from 0 to 2, 0 to 2, sorry, 0 to 2, yeah, 0 to 2. So we have here 0 to 2, then you get 4 over 6. Okay, so now you get, you already have these 3 values. Okay, we still need to check, because if you shift this again, you will get, still you get value, okay. So we are going to find next t equal to 2, y2. Let's look at this. So we read out directly y2, 3, 2, 1. You see that it's still overlapping, kan? Because this signal is until 3. So I'm going to write here 3, 4, 3, 2. 2 and 3 still overlapping. And then number 4, 5, 4, 3. Okay. So at this point, actually, sorry. At this value, your y is 0, and as this value at y4 is 0. Okay, the rest you has a value. So this one is do at home lah. We don't have time, really at almost 10. So try to do this at home. Okay, continue up until t equal to 3, t equal to 4. Okay, so you have 2 more. Then you will find out that you can plot the graph. Then that graph we will discuss it next week. Okay, so can we do that? And then after you plot, after you get all of this, plot for y. Okay, plot for y. Okay, that will be all. So I think that will be all for class today. And if you go to the slides, I already upload, I already add some example. This is one example of midterm and final exam. Midterm, I think. So convolution integral, you can look at some other examples. Same thing, you can see here that it's not, you are not given any signal, but you need to plot it. So we have here, you can see directly that HT is actually a ramp signal. So find that. And then another example for convolution integral is that you're not given any equation like this, but you need to derive it based on your chapter 1. Hello, guys? Based on the chapter 1, means that plot what is RT based on chapter 1 and then do the convolution. Okay. This one is two signal. Okay, two signal. And then another one, SLT4 is also same thing. You have considered two signal given by this and then do the convolution. And lastly, another signal given by these two signal and do the convolution. So lots of exercise, please do it at home. Okay, and the last part of chapter 2. Chapter 2 will be the property of LPI system, but this one I have uploaded in appendix, so please read it on your own, the property, and that will be the end of chapter 2. So for MATLAB exercise, you can go through this example of exercise. Hopefully by now all students have a MATLAB, and because you have already gone through one of the lab session on using MATLAB. So use this, prove your answer for the graphical method using MATLAB. So I have actually shared to you some coding and then try to actually answer this equation. But I think this one is the same that we have discussed in class. So you calculate manually and then prove it using MATLAB. Okay, so that will be all for chapter 2. Okay, there's a question in the chat. Doctor, is it necessary to draw the graph for each? Yes, necessary. Because if you don't draw the graph, right now you may think it looks simple. No need to draw graph pun tak apa kan. But you imagine later on, your final midterm exam will not be this easy. Okay, you don't do a graph, and if you make a mistake, then basically, if you draw, you calculate, you can't just calculate here without doing this one. But apparently, this equation is wrong because you didn't draw the graphical. And for convolution integral, is that name is using graphical method. It means that you need to draw the graph. Okay, and not only using equation. So draw out the graph, need to show that, because this graph also have marks. So if you don't draw it out, then no marks. Okay, so that will answer to Alif. Right, any more question? Okay, so don't forget, we have in Padlet, the task, I asked you to upload only one task in for convolution integral to Padlet. And then also for the rest of the exercise, please do it on your own. I'm not going to give to ask you to submit any exercise you learn. Okay, and before we end class, make sure that go to class reflection. Okay, click on class reflection, you can submit your class reflection for this week. Okay, so comment lah if what do you think? Is it too fast for the convolution integral? Because I think I'm teaching very slow, it's slow lah, okay, compared to teaching in front. But anyway, you can comment if it's the pace is okay and so on. I will try to cater to all of the students. But as a rule of thumb, if you want to get A for this subject, guys, I think, can you hear me actually?
Yes, we can hear you, Doctor.
Okay, because I think there's problem with FX, they're on off my side, because it's okay. Anyway, hopefully you listen just now. Recording, I think just now recording was also interrupted. So anyway, if you have question, you can just comment in the feedback form. Okay. Oh, you learn this down. Maybe
yeah, I cannot
connection.
access Yulen.
Yeah, okay. Anyway, the you learn the feedback, you can do it up until 12 in the afternoon. Okay, so you can do that later on. All right, that will be all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye.
Thank you very much, Doctor.
Okay, submit it at 12. Not now lah. You still can do it until 12. Right?
Sorry, Doctor.
Yeah.
I don't even take the attendance but now the Ulen we can't access, right? So I haven't done my attendance check-in.
Then you come late ke?
No. I forgot to take the attendance because I very focused in your class.
Okay. All right, I will open it extend until 10:30. Okay. All right.
All right.
We'll open that later. Okay. Thank you.
All right.
Anyway, that will be all. Okay. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Bye.